Our prototype design incorporates a variety of materials starting with the basic wooden structure of the display case. We also acquired a small aquarium pump and latex tubing with a small quart-sized bucket at the bottom of the display that will act to catch the water that is siphoned through the tube. The aquarium pump is placed in the bucket to create a water circulation method that works virtually indefinitely, with the water being continuously ran through the pump and the latex tubing. We also bought a 5 1/4-inch subwoofer that, once hooked up with an amplifier and our Arduino, will output a 60 Hz sine wave to break the water. To vary the effects of the water illusion, we have programmed our Arduino with the code necessary to output our desired frequency and also vary the rate at which our LEDs can flash. We will now discuss in more detail our manufacturing process and the functionality of our prototype display.
Beginning with the main display, we purchased sheets of wood and sized them appropriately to be assembled into a basic display box. Using a table saw, we cut the large piece of wood into 5 pieces, 3 3x18 pieces for the sides, and 2 6x8s for the top and bottom. We attached 2 sides with the top and bottom in order to create a shell. We then used a drill press to cut out the hole for the speaker and the back panel, as well as a power drill to place holes around where the speaker would soon go in order to mount it to the box. We then attached the back panel to the shell with a nail gun, nailing it into place. Finally, we attached the subwoofer with screws, nuts, and washers found throughout the project depot of the ITLO.
Because we were missing an amplifier that will help output the frequency through the subwoofer, we had to use our hands to sync the flow rate of the water with the flashing LEDs by pinching the latex tube. However, when we have an amplifier connected to the subwoofer, it will be much easier to break the water to a rate that matches the frequency of the LEDs by outputting a 60 Hz sine wave. This sine wave will break the water in a pattern that will match the frequency of the flashing LEDs and create the desired illusion.
Another major part of this project is the pump and tubing, which is responsible for the entire water circulation system. We bought a submersible 80-gallon-per-hour fish tank water pump with 1/4-inch latex tubing, which is dropped into our water catch, then pumping the water back through the tube, back through the system. The issue we have had with the pump is that it initially wasn't strong enough to push the water up the tube. Even though now the pump works, we are not sure how it was fixed, and our possible solutions would be to buy a stronger pump or to constantly have water pressure already inside the tube.
The Arduino and LEDs are our final critical components of the display. In the final stages of the project, we want to control the frequencies of both the LEDs and the subwoofer, and want to turn the water pump on through the Arduino. For the prototype, only the LEDs can be controlled from the Arduino. The LEDs used for the prototype are a 12-volt strip of LEDs, which need a 12-volt power source, which is currently an adapter that plugs into a wall outlet. In order to run 12 volts through the board to power the LED strip, a MOSFET transistor is used. To vary the frequency at which the LEDs flash, a potentiometer is connected with the board. This is what happens when the potentiometer is changed.